All right, in this problem, we've got students who are going around to track training for a marathon. One of them is walking 22 minutes a lap. The other is running 8 minutes a lap. And we're going to assume that their times are constant and they just keep going for hours, right? Just forever. How long would it take? And here's the key part. How long would it take until they pass each other at the starting line of the track? So they meet at the starting line of the track at some point. And then how long is it until they meet again at the starting line? Now, if it weren't for that phrase, at the starting line, it wouldn't take long, right? A little more than 8 minutes. And in 8 minutes, the quick one's going to make it around the track again, and the slow one's not gone very far, so a little more than 8 minutes, maybe 10, 11 minutes, they're going to pass each other again. That's not what it's asking for. It's asking for how long until they pass each other at this particular place. So the easiest way to think about this, and not the quickest way to solve it, the easiest way is to just think in terms of lap numbers. So lap 1, lap 2, lap 3, and just keep on going for 20 laps or so, I don't know. And we've got the runner and the walker. Well, the runner makes lap 1 in 8 minutes, lap 2 in 16 minutes, lap 3 in 24 minutes. The walker does lap 1 in 22 minutes. So you can see that they almost actually passed each other at the starting line right here. Not quite, so it's not good enough. We need to find where those times exactly match up. So you can either just keep on going out until you find numbers that match exactly, or what we can do is think about this as a least, this is the style of problem this is, a least common multiple. So in other words, if you multiply the runner by 3, you get 24. The walker by 1, you get 22. What's the least common multiple? In other words, a number where I could multiply 8 by something to get that number and 22 by something to get that number. So what you do here is you do factor trees. You see here what I've done is I've factored the number 8 into its factors, 2, 2, and 2. And I factored 22 into its factors, 2 and 11. And to find the least common multiple, you simply create a product of all these factors, where you only have as many factors as is required to have at least as many as you had in the individual products. So see here, for example, I've got 2 times 2 times 2 in that factor tree. So my least common multiple has to have 2 times 2 times 2 in it. And over here, I've already got the number 2, so I don't need that again. I don't need 4 2s. 3 2s will do it. Okay. I don't have any 11s, however. So this guy right here needs to be in my least common multiple. I only need one of them, but I do need one of them. So I get 2 times 2 times 2 times 11, and that makes 88. And if you think about 88, let's just double check ourselves here. 88 divided by 8 equals, that's 11 laps for the runner, and 88 divided by 22 minutes, that's 4 laps for the walker. All right, so they do match up. It's going to take a little while. My runner's got to hang in there.